guys, welcome back to Paraclete TV. Today we'll be talking about lines and slopes, proportional relationships, and what it means to have a linear proportional relationship, as well as talking about the details of a line, so what the slope means, what the intercept means, positive, negative, things like that. Alright, let's get into it. Alright, so let's get into it. So let's first talk about the slope of a line. I did do a video on the slope earlier, so if you need a more detailed explanation, go there. If not, we'll just talk about it really quick here. So slope is basically the y values over the x values, rise over run. So as you go up the y-axis and you go over in the x-axis, you create this relationship, which is a proportional relationship that we also talked about. But we define slope as the variable m. And it defines the change in x compared to the change in y. And so when you get to higher order math like calculus, your slope becomes your best friend. You have to calculate it all the time. So getting the basics down is very important. So slope is how far you travel up compared to how far you travel over. It's m. It is a proportional relationship, so it's always constant. So if you're traveling this much x, you're still traveling the same amount of y, compared to if you travel that much x, you're still traveling the same amount of y, and so forth. So the basic and the most common linear function form, or like how you would see it written, is going to be y equals mx plus b. And many of you have probably already seen this before. So here we have our variable y, which is our y-axis, our y variables. And this is saying that y is proportional to x with this by the slope m plus a constant, or plus a number. Now this number is called the y-intercept. And as you can guess from the name, it's a point on the y-axis where x is going to be 0. So our y-intercept is where the line intercepts the vertical axis, or the y-axis, and x equals 0. Now this makes sense because if we were to plug in x equals 0 in this equation, 0 times anything is going to be 0, right? So this term cancels out, and we're looking for y now equals just this constant b. Sorry, my dog is moving around. Okay, so basically the intercept is the initial condition, and it's what is happening right before we start measuring. Where are we in space? Where are we in time? That kind of thing. So let's just look at a problem and I'll walk you through it. We'll say we're doing a physics experiment and we measure a car is moving at a constant rate of 65 miles per hour after it has traveled 65 miles. How far is it after 3 hours? And this is it specific. After 3 hours of traveling at a consistent rate. Constant rate, we'll say. Alright, so our first thing we have to do is establish where we are when x equals 0. So we start measuring a constant rate, and when we hear constant rate, we need to think slope, right? Because we talked about that in the other video. Constant rate is slope. So we have a slope of 65 miles per hour, which makes sense because we're increasing in our miles and we're increasing in our time. Miles per hour, we know that that's going to be a fraction of miles over hour, rise over run, so that makes sense. 65x. After it has traveled 65 miles. So at our starting point of our constant rate, so as it becomes linear, we're already at 65 miles. So we need to increase our value in y because we're not starting at 0, and we need to account for the 65 miles, especially when we're counting than when we're trying to measure. So this initial condition here, excuse me, this initial condition here of 65 miles is our intercept. And that's when x equals 0. That's before the constant rate starts happening. And once the constant rate starts happening, we're going to add on to that 65 miles. So y equals 65x plus 65. And so how do we draw this? Well, our intercept always is at x equals 0. So we know that 65 is going to be on the y-axis, and it's going to be when x equals 0, so it's here. And now we have our rise over run, and we have units of 65 here, and we'll do these are units of 1, 2, 3, 4. So for every 1 mile, right, because we have 65 miles per 1 hour, so for every 1 hour, so every increment over of x, we're going to go up 65, right, because it's rise over run. So we'll have that, and we go over 2, and we have to go up another 65, and we go over another one, right? So then this becomes our line, where the intercept is not 0 because we already started at 65 miles. So now the question is, how far has it traveled after 3 hours? So we have hour 1 here, hour 2 here, hour 3 here. So this is how far it's traveled. It's traveled 260 miles after 3 hours. Thank you guys so much for watching this video on intercept and slope. I hope it helped, and I'll see you guys next time. Bye. Thanks.